Hello again.
Hello, Marina, and welcome to the
Um,
second episode of PIT Chats with Marina Kirkitadze. Today, we are dedicating the session to software for PIT, from data to real-time decisions, with the objective of position software. You know, what is it? What is it that we are using it for, and what is it that we are not using it for, and the criticality of it, Marina. So, how does this sound?
Very interesting. And also have some slides here. But what I would say about software is that I think we mentioned in the previous conversation that we need software that's overarching or bringing connecting dots, connecting all the probes together. So it acts as one orchestrated, one organism, one team, if you will, digital and technical, but nevertheless team. And so with that, of course, if you have a software that connects signal together, then it plays as the operating system for process understanding and control. And if it's basically disconnected, so you have individual probes, but they are, have their own softwares. They are disconnected signals, they're isolated instruments, and you have scattered data files. So with that, of course, the danger is that many things uh, you collect the results, and they may be very interesting, but we cannot use it because they're not linked, and hard to make decision, hard to make conclusion, and subsequently hard to make decision based on that. So
A bit the data mess, right? Sometimes where we
yes,
acquire, but then we cannot make sense of our data, and actually we spend a lot of time going through those data.
exactly, yeah. So I think you have another question, and you're nodding.
Yeah, yes, it's about of you comment. I really very much like that you comment word orchestration and the one team, how important it is to synchronize everything that's happening at the same time, because we're doing real time. In the last episode, we talk about the ultimate goal to release while we are manufacturing. And to be able to do this, the synchronization has to be there. So the similarity of an orchestra where there is a teamwork and then everything is in sync, I think it works very nicely. But also the concept of operating system for process understanding and control, fantastic statement, very nice. Now, I guess not all software meets the requirements, though, to be able to execute the task, because this is not, we're not talking about, again, software executing one task. We're talking about synchronization, and we're talking about more
Yes.
complex functionalities. So what are, in your opinion and experience, the requirements for software?
I think I can share the slide just to give a little bit of visual. But I think we're talking about core software requirements, and usually there are, well, at least 8 characteristics one can mention. So just move this. I can give the full screen for you. So one is the real-time data acquisition and monitoring. So it's given. So we need to have to capture live data from the probes, analyzers, equipment. We also need to retrieve sometimes data from historian to across the inline, outline, all out. So it's real. It's real. And then time synchronization across probes and equipment. So just like you mentioned, it's one. It's if you're one team, so we're kind of working same. I can't say same speed, but at least aligned in terms of timing and probes and equipment. So you have, for example, Raman and IR, pH, pressure, and we need to know it we need to see it on the screen at the same time. That's why I put visuals, so you have different columns, but they are linked to some other columns that at the background, so you can see the picture, like the whole picture, as much as you can see, of course, whole picture. Then the next one is centralized data management. I think we kind of touched a little bit on that data management is essential. We cannot afford to have data mess. It has to be structured. It has to find its own spot. And main thing has to be retrievable. So it's raw signals, it's results, and also narrative. What is it about? Is it batch number? Maybe even operator number. Who launched this batch? Recipes, like, so what procedures were used, linked to these procedures. So always, has to be linked together. Maybe coding or, numbers, but for person who reads it, it would be easy to see or retrieve like what this coding means and what is associated with this data. So data management is essential. Then integrating with the process and quality system. So not just data by itself, but it has to be, I guess, traceable, right? It has to be, consistent, like feedback records, control strategies, investigation. So this data is useful for any audits, internal audits or external audits. It's very easy to show how you made the decision. Then the next one is model. We touched on that the model can tend to drift and they change. So what you do with it, you have versions, right? Then version is validation. So yes, there is a drift, product still within the spec, process drifts. You do additional validation, right? Like sometimes they call mini validation, depends what teams you're talking to. And it's amendment to existing, or it's brand new report, but they have to be linked to demonstrate that the model is valid and can be used to analyze data or to make decisions based on the results. Then the next one doesn't want me to move. Yeah. Alarms and the workflows and decision support. So alarms. So we go beyond. So something goes wrong. It's not as expected. It drifts. How are you going to get these alarms? Only at the shop floor, maybe even on mobile devices. Sometimes, I heard, for example, from one of the colleagues that they get the report on mobile device, even if they're not at work, and they know, for example, glucose concentration drips, and they need to, act quickly. So alarms are very important. And of course, how you set the alarm. Is it 80% difference? Is it, just 10% difference? I mean, like 80% tolerance level, 70%. What is the tolerance level? Then scalability, standardization. Standardized methods, standardized templates. I think with standardization, it's one of the toughest thing, because by nature, any research and development, creation of a process is a very, I can't say individual, even if it's teamwork, it's still unique in a sense. But once it becomes the manufacturing process, has to be standardized. So no matter who does it, no matter where it happens, it has to adhere certain standards. That's sometimes hardest part. Maybe easy for machines, but harder for humans to achieve. But nevertheless, have to be done. And then, of course, compliance, auditability, data integrity. That's actually critical. All those items are important, but this one probably critical: e-signatures or trails, and metadata, right? Like as mentioned on previous slide, what is associated with it, to what batch is linked, to the operator, to the procedure, where, so when you retrieve one piece of data, you kind of pull the whole picture, where it comes from. It's like a train of different wagons, and each of them represents from qualification, validation to the actual batch procedures used. So bottom line is not just more data to collect by PAT. It has to be right data synchronized. It has to be contextualized, meaning it has enough metadata to understand what it is, and it's validated. So this is critical.
So we can make decisions from the data, on the fly decisions, and
decisions. Yeah.
And then with that, it triggers the question on on-the-fly decisions? Are these decisions AI, ML driven? Are they there is some artificial intelligence built on those decisions, and how does this feed into the regulatory landscape?
So basically, from data to decisions, I think one needs to translate raw spectra, sensors, deviations into the meaning. So what does it mean? What does it mean for the product? What does it mean for the process? Can we continue to, with the process to reach the final step? Should we stop? Should we investigate? Then a comparison against process understanding. So benchmark live performance against historical or golden batches or validated models. So this helps to establish CP, to compare with established CPP or CQA relationships. And then I think back to the question you asked, what is the predictive insight? So forecast, endpoint, timing, yield, quality, to detect early signals of the drift. They don't happen yet, but you already see decline, or opposite, it climbs up, kind of too fast. So may not, will be out of range soon. So then identify and use these adjustments. So these things, I believe they have to be linked to the machine learning. We often talk about machine learning, but what it really means, it's models, right? So it's basically what the data you feed, the models you feed, and then you check whether the models is correct or not, whether it fits the range that you define to be used for validation. So I think I have a visual here. Maybe I can do this one. So for example, so with machine learning, why we want it, and with AI, is to make the decisions faster. So cut the time from signal by action, by surfacing recommendations, flags, and so forth. And also another part is eliminating interpretation bottlenecks. So often, if you have issue, it's a team getting together, discussing, asking subject matter experts to be involved. And they may not be necessarily in the theme right away, so you have to bring them up to speed. So it becomes slow, very slow, and very costly because it's investigation, the most costly exercise in the industry. So here, I suggest that, I think from the software standpoint, if you have machine learning, you can make decisions without experts being involved over time, because it will be certain range. If it adheres certain range, you pass. If not, then of course there is something to go back. By most part, with the machine learning and AI can make decision to move next. I guess many people will argue that AI has to, be well trained, right? But nevertheless, it's a pool of data. It's huge memory. So and it's quick in terms of responding. So it can be used as a depository with the ability to analyze. Then I think it will help dramatically to be faster. So from dashboard to control strategy with AI, you can definitely move faster to make recommended adjustment or enable validated closed loop control, meaning if you need to increase, for example, certain compound and pass to next step. So I would say in summary, its interpretation layer. Is the process healthy? Is the quality at risk? And what decisions come next? So those definitely are part of machine learning and AI, where it can be helpful and much faster to help us to move on.
Excellent. And does this part get into the filing? I'm thinking about the regulators, right? I know that possibly the regulators are thinking, well, we encourage you to innovate. That is all about getting better quality, higher quality, and that's not negotiable, right, for a pharmaceutical industry. And sometimes Well, when I think about it, I used to do structural elucidation in the past, and I used to do computer-aided structural elucidation. And sometimes the proof of structure will go into a filing document. Is well, I checked everything. I mean, it was me who did the work at the end, but aided by the tools that I had, computer-aided tools I had at the time to make me go faster. But ultimately, the decision was mine. So does this relate what is happening today in PAT and the use of AI or ML? Is it that it is just supporting information or material that we use, but ultimately is the human making the decision? So how do we go ahead on, for example, validating series of processes or steps? One of them has AI in it. Can we assure that we're going to get representative, validated results, that they're always within the expectations? Does it make sense what I'm asking?
It is. It's I think very, let's say, not fresh, but timely, maybe timely question, timely discussion, because um, I think at present it's still, and it will for maybe a long time, it would be for human to make final say, right, and make a decision. And again, the AI as a depository, it knows what we know collectively, like what we put in it collectively. It's machine learning, but machine learns from us. Whatever data we collect or allow, it collects from the instrument that is used, or array of instruments, PAT props. It collects and it becomes a depository that is analyzed, or creates a model against which we compare the result. At the end, we can make decision, but nevertheless, if you teach AI, for example, that certain range is acceptable, then it will tell, okay, I cannot accept this. It will be a decision, and it will stop operator if, for example, the quality of compound is not appropriate. And I saw, for example, that they want a certain value to be achieved when they wait, I don't know, let's put salt for the buffer to be prepared. And the salt has to be from certain, I don't know, company or certain quality. It's better to say, because companies can change. And if it's not matching, it's not what's written on the badge, on the label, it will not accept. It will give you banner. So it's like, no. So those things already, like yes, no, computer made decision. I'm not sure if it's AI, but in a sense it is. It's already machine learned. This is prohibited, and they will not let you to another step. This is allowed. Okay, you pass. So those steps already, implemented in a preparation step, for example, in a manufacturing slate. And one of the teams, they basically showed it. I mean, this is stops you, but at the same time, you don't make mistake. It does not let the operator to make mistake. So this I think works to our advantage. Where it can be difficult if AI interprets too much. Even if you ask AI, for example, to check your text, I'm just Word document. Sometimes it paraphrases so much that you see that the meaning disappeared. So I think this is where human has to be very vigilant, whether if it's AI checked, is it still meaningful? Is still related to the product? It's not something that this tool took from other sources and dissolve the value, or give you the picture of completely different thing. It's not your product altogether. So these things where human intervention and critical thinking has to be used, and human knowledge is basically priceless from that regard. Whether it's SME, whether it's operated hand, collective knowledge as a team has to be as a verifier. Otherwise, it can bring us to strange situation, if not dangerous. But nevertheless, as we go and as more machine learning pitching occurs, more data is absorbed. We can see more and more machine-decided steps that, certain step is accepted and certain is prohibited, and it's to our advantage. So that if operator is in doubt or new or, not in the mood today, made wrong thing, there would be blockage, and the mistake will not be constituted a catastrophe for others to clean it up and do investigation and then do CAPAs, because it's manufacturing. So it's not just sorry, I had a bad day. It has to be, actions, investigations, reports. It's a lot of documents have to be put in place before you restart and proceed. And of course, it's also reported to regulators. It's not just, it happens and nobody knows that you have to report. So this is very serious. So it has to be taken seriously. But where machines can help, of course, I think I'm proponent. Yes, the polish. Yeah, the process becomes more streamlined, easy to grasp. But it does not eliminate humans from thinking. You still have to think, be vigilant, be very critical, and critical in the sense to see the gaps and potential issues, and and work together.
Yes, and as you mentioned previously on how important it's the quality of the processes that we are controlling, the quality of the data that we feed into these models, that is, without saying, critical, so then we don't create the situation of garbage in, garbage out, together
Yes.
with a very, very strong data architecture and strategy that supports the whole thing, the working together as a team, all synchronized, all the bits and pieces orchestrated and in sync. And with that, I wanted to ask you, we're going back to the beginning analogy. So what is the risk of having PAT or implementing PAT, but not the right conductor, not the right orchestrator, not the right software to use it?
Well, it has a chance to getting data without context, right? So you have PAT, but you don't have right software. So the signals come from different probes. They're not synchronized. They disconnected. So it's not consistent, or it's not meaningful. Does not lead to decision. He, if a person does not really believe in PAT, he will or he or she will look into the what is the let's return back to manual, how it was. It was working, it created value, so easy to kind of revert back. But in a way, there is another thing: slow decisions reduce PAT value. So if people who implement PAT put too much checks and balances, I understand that checks and balances are important. But if you have too many control steps, that overall slows down the decision, that diminishes the value of PAT. You don't see the speed. PAT is meant for speed, right? It's not, it doesn't mean many people, when, in manufacturing, you tell them move faster, they always look at you with suspicion that faster means less organized, sloppy. So they always have this negative connotation, but fast doesn't mean faster than your process. It means with your process is how it eludes or ferments you right there. And because we are different nature, we cannot be always right where. So we need support with instrumentation, with software that checks and gives us this chance to be right there at the next step, to meet when it's ready, not tomorrow, day after. So basically the idea is of continuous manufacturing, which is very hard in biologics. Everybody knows it's batch production. It's always a cycle. It's very like night and day. You go around, and next day something again. Next batch, some surprises happen. We want to go to continuous. How to get there? So to bring into continuous, that's where PAT helps. It's just right time to meet and be ready for purification, for example. Yes, your next cycle will be for fermentation, but at purification, the operators or scientists or engineers, whoever working, the team, let's put it that way, they don't sense that you have another cycle to start. They have enough material to carry on. So I guess for people who implement PAT, also important to get this bigger picture in mind, and how they help others, not what the slows them down and risk, but also how help. But as I mentioned before, when somebody implements, their risk, if a person is very low on risk taking, like risk tolerance, their essence have to be addressed. With what? I have a gap. I will never fail because I have this manual, offline technology right with me. So whatever happens, I carry on. So then they would be less, how to say, hesitant, perhaps, to give a chance for PAT to carry on. But don't slow the decisions. I would say, manual interpretation, and also, like if it's, you have data, but it's not with all the connotation and it's not retrievable or it's not real time, then the scaling becomes difficult. So without standardized software, you cannot move across the products, across lines, across the sites. So then investment becomes not really useful because it does not bring to the ultimate goal faster batch release. So.
Excellent. And you just said moving across sites. And this will be the topic of our third episode of PAT Chats with Marina. And with this, we will conclude the second episode, and we are looking forward to the next one. So join us if you want to hear more about data sharing and process sharing, PAT across sites, including the CXO ecosystem. With that, I would like to thank you, Marina, very much for being with us today. Thank you.
Thank you, Anna. Thank you.
Bye-bye.
Bye.